All right. Good afternoon, good morning, good evening, depending on what time you will be seeing this video. And welcome to our Jamb and WAEC tutorial class. Some of you already sent a message that you want a video on alternating current. So I am dropping this because of your request. And if you are seeing this channel for the first time, I want to encourage you to subscribe to this channel, turn on the notification bell, so that as we draw more videos like this in physics, in chemistry, in biology, in mathematics, you will get notified. So without wasting time, let us go straight. The first thing we are going to be looking at is the meaning of alternating current. So if you go to your physics textbook, they call it the AC circuit. So very quickly, there is something they call electric current. And many of you use electric current in your houses. You use electric current to charge your phone. You use electric current to watch TV. You use electric current for your AC, to boil water with your heater, and many things. But I want you to know this afternoon that there are two types of electric current. The one that you are used to is called direct current, but there is another current that is called alternating current. So the current that you use at home anytime that there is light in your house, that current is called alternating current. The current that carries your phone, the one that carries your fridge, it is called alternating current. So quickly, what is alternating current? As you can see in the note, alternating current, usually called AC, is an electric current that flows forward and backward. That means it goes forward, it comes back. So in proper terms, we say it is a current that flows to and fro. Alternating current flows to and fro. Then the second type of current is called direct current. It's a current that flows in one direction. Direct current flows only in one direction. So now in physics, hear what I said here. I said we can say that AC flows in a sinusoidal waveform. AC flows in what? A sinusoidal waveform. The word sinusoidal comes from the word sine. You know sine in mathematics, when you say sine theta, sine 30, sine 40. So mathematically, in case you don't know that, maybe one day I'm going to drop a video. If you plot a sine function, a sine graph, you are going to have this shape you are seeing now. And I want you to know that this shape, anywhere you see a graph like this, it simply means it is representing something that repeats itself. So look at it from here to this place. What happened here will repeat again from here to this place. What happened will repeat again from here to this place. So it is a repetition. And because alternating current is current that goes forward and comes back, go again, come back, go again, come back, we say that it is a current that repeats itself. So we can use this wave function to represent alternating current. So that is the first thing. I like you to understand that we have two types of current. One is alternating current, one is direct current. So very quickly, the next thing we are going to look at is that there are some formulas that you will need when you are dealing with alternating current. Though this video will not carry all that current because this is an introduction video, but these are the basic things that you need to know in order to survive the question that Jamb and WAEC can throw at you from alternating current. So the first thing is that I, which depends on time. Don't forget that in physics, letter I stands for current. Is equal to I0 sine omega t. Look carefully, this sign is called omega, but we know that omega is equal to 2 pi f. So we can now say that I, which is the current at any particular time, is equal to I0 sine 2 pi ft. That means we are using this 2 pi now to represent omega. So if you remove omega from here and put 2 pi f, you will get sine 2 pi ft. Now it is important that you know the meaning of each of the symbol. What does I0 stands for? I0 is called the peak or the highest current. The word peak in English means the highest. So I current means the highest current. Then as I told you earlier, this symbol that look like W is called omega. It means angular frequency. Then F is the normal frequency that you know, and T is the time that the current flows. So there's another thing I want you to know again. I say note that current and voltage are together. They are together always. Anywhere you see current, you must see voltage. So because of that, we can also write for voltage. So if you enter current here, you remove I and put V for voltage, then the I0 will become V0. So we can now say that voltage at any particular time is the peak voltage sine omega t. The peak voltage sine omega t. All the symbols have their usual meaning. What that means is that V0 is the peak, that is the highest voltage you can get. Remember, we say that alternating current move to and fro. The current is changing all the time, but the highest you can get from a particular alternating current is the one we call the peak, which is I0 for current and V0 for voltage. Then very quickly, before we ramp up this video, I don't want it to be too lengthy so that it will not get boring. The final thing I want to say in this video before I give you what to do for me is what we call the root mean square value. In alternating current, there is something called root mean square value. Now RMS value. I want you to know that current has it, voltage has it. So the two formulas are very simple. Formula number one here say root mean square current. You see now I is current. RMS means root mean square. Is equal to I0 over root 2. Don't forget that I have earlier told you that I0 is equal to peak or highest current. So if you want to know the root mean square value of the current, divide the highest current by 2. The same thing happens for voltage. If you want to know the root mean square value for the voltage, you are going to divide the highest voltage, which is the peak voltage, by root 2. Okay, finally, let us see if you are following everything that we have said. Look at this example 1. It says if the peak voltage of an AC circuit is 230 volts, calculate the root mean square voltage. Like I told you, root mean square voltage is equal to peak voltage over root 2. So if you carry your calculator and divide 230, which is given in the question as the peak voltage, you divide it by root 2, you are going to get 162.6 volt. Then look at example 2. Example 2 says if a main supply, that is the main current supply, is 50 Hz. Don't forget that Hz is the unit of a current, of a frequency, sorry. And then the peak voltage is 230 peak. What is the angular frequency and the root mean square voltage? So the first question asks for what we call angular frequency. Don't forget I told you earlier that angular frequency is 2 pi f. So this is the 2 and pi is 22/7 and the frequency given in the question is 50 Hz. So we multiply by 50. So if you do 22 times 2, you get 44. 44 times 50 will give you 2,200. All divided by 7 will give us 314.3 radian per second. Then the second part of the question asks for the root mean square value of the voltage. Don't forget that the formula is peak voltage all over root 2. Peak voltage in the question is T230. Divide by root 2 will give us this value. So thank you very much. If this video resonates with you, I'd like you to go over it again, understand it. The next time I'm going to be bringing the part 2 of this video is going to take us into resistor, capacitor and inductor in AC circuit. And after that one is done, there will be no question from WAEC or Jamb under AC that you will not be able to handle. Meanwhile, before you go, as I'd like you to look at this question, look at this, now try this, look at this, try it and tell me what your answer is in the comment section. Don't forget to subscribe to this channel, turn on the notification button so that when I upload more videos, you will get to see them. Thank you and have a nice time.